All right, welcome to lesson 10.4, perimeters and areas of similar figures. So our learning target is I can use ratios to find the perimeters and areas of similar figures. And ratios is really going to be our key kind of thing that we work on and focus on today. All right, so a quick little do now here, just as some review. We're going to find the scale factors from the left figure to the right figure. And remember when we do our scale factors, we do that ratio of 2 over from, and yes, sorry, I'm using my hand to write again today. So if we're going, for example, in number 1, we're going to the right figure and we're going from this left figure, you do 2, 10 over from 4, right? And then simplify your fraction. So take a minute to do that, and then I'll go through these real quick. All right, so on number 1, if we have 10 over 4 as our scale factor, I'm obviously going to want to simplify that down to 5 over 2 and leave that guy as my scale factor. So as I go from this shape to this shape, it looks like I'm actually getting a little bit larger, right? It's an enlargement, and so my scale factor is greater than 1. It's 5 halves. As I go to this shape, from this shape, I'm going to have 6 over 14. Obviously, I'm going to want to simplify that, and it looks like I can divide them both by 2, so I'll get 3 over 7 as my scale factor. And then again here, we're going to say that this guy is our left and the 6-foot figure is our right, so I'm going 2 here from here. So I'm going to put my 2 over from, so I'm going to go 6 over 3, and then that just simplifies down to a nice simple 2 for our scale factor. So just a quick little bit of review for scale factors there. Remember, we are actually going to work a little bit with proportions today as well, which is where we have fractions that are equal to each other. And remember when we have proportions, if there's an equal sign in the middle, we could actually have them flip-flop, right? I could have 14 over 6 equals 7 over 3, and just keep in mind that the order of the fraction isn't as important when we're setting up proportions. All right, so if you guys remember, I gave you this chart as your lesson 1, and you had to go through and fill it all out. The point, remember, is not that you just have all the right answers written down. The point is, did you think through it, and did you actually kind of get some idea of what's going on as we go from the first perimeter to the second perimeter and the first area to the second area, right? So I asked you guys to pick 3 rows, create a ratio out of the perimeters, which bing bing, ratio is a keyword for today, and then a ratio out of the areas left to right, and then to just kind of look at like, what do you notice about the relationship between that original ratio and the new ratio? Then I also asked you to write a sentence describing the difference between the changes in perimeter and the changes in area. So one thing I hope you guys will notice is that your change in side length and your change in perimeter are always going to be the same, right? If you double the side length, then your perimeter is also going to be doubled. But then when you get to the area, kind of the key thing to notice here is that the perimeter change compared to the area change is actually being squared, right? If it's 2 times as big, well, 2 squared makes 4. Down here, I believe we said the perimeter change was 5 times as big. Well, the area change was 25 times as big, right? On this second row, I think we had a perimeter change of 3 and a side length of tripling or times 3. And then the area change ended up being times 9, right? So you should see kind of a normal regular number and then a squared number in that area change. So that's kind of like a key to what we're going to talk about today. So here's sort of some formal stuff about section 10.4. So what we need to remember is that the scale factor of 2 similar figures is going to be A over B, right? There's my ratio. Then the ratio of their perimeters, and we use this fancy notation, capital R ratio and lowercase p for perimeters, is A over B. And notice that those guys are the same, right? If I'm making ratios. Okay. And then this is kind of the fun new thing, is that the ratio of their areas, the capital R little a ratio of areas, is A squared over B squared, which hopefully you guys noticed that in your chart that you worked on yesterday. Okay, so I'm going to show you a couple of examples here. The first one is just how do we find the ratios, okay, and not like what they're useful for. I'll mention that in the next slide because they are super useful. But here, just how do we find them? So here it tells us that the trapezoids are similar. The ratio of their corresponding sides is 6 over 9, which simplifies to 2/3. So this here, this number, let me change this to red, this is actually our scale factor, right? It's just the ratio of the sides. So the first question that we're being asked is, what's the ratio of the perimeters? And notice that it has this little notation of smaller with the colon and larger. That just means they want the smaller number first and the larger number second. The ratio of the perimeters, remember we said, is exactly the same as the scale factor. And that was what we noticed in our in our table as well was that if the sides are doubled, then the perimeter is also doubled, or if the sides are tripled, then the perimeter is tripled. So same thing going on here, right? If my ratio of my sides is 2 to 3, then my ratio of my perimeters is also going to be 2 to 3. So then the next question asks, what's the ratio, smaller to larger, of the areas? So we noticed on our table that if the perimeters doubled, then the areas quadrupled, right? Or if the perimeters were tripled, then the areas were 9 times as big. So we're just squaring, right, the original ratio of the perimeters here. So we're just going to take 2/3 and square both of those numbers, and so the ratio of our areas is 4/9. That's all you have to do when it just asks you to find ratios. Just find the scale factor, copy it down for the perimeters, and then square it for the areas. That's it for these types of problems for this example 1. So we'll get into in the next slide, what use are these ratios, right? What's the purpose? So here we go. We're going to find areas using similar figures. So we have 2 pentagons here that are similar. It tells us the area of the smaller pentagon is 27.5 centimeters squared, and we need to find the area of the larger pentagon. So if we were using tools and kind of techniques that we had last week, we would say, oh, well, no problem. I'm just going to find the apothem and then do 1/2 apothem times perimeter. The only problem here is that if I go through and I start kind of drawing in my radii and drawing in my apothem, and there's 5 sides, so I would do 360 and divide it by 5, that gives me 72 degrees. And then if I have my radius, right, because it's like a chunk of the radiuses going around, if I split that radius down the middle with an apothem, that breaks that kind of chunk, right? If I had split that up and that was 72 degrees and I draw my apothem in there, sorry, that's horrendous, but that would give me like a 36-degree angle in there, right, to try to figure out what the apothem is. And that's not a special right triangle. So at this point this week, we're not going to be figuring that out. That's a topic for next week. We will learn it next week. But for now, we actually do have enough information to figure out this area without having to do a bunch of hard work to find the apothem. So here's what we're going to do. My tip is to use a proportion, right? And a proportion, remember, is just 2 ratios that are equal. And then we're going to cross multiply and divide and just kind of do a solving process. So to start off with, we know that the ratio of the perimeters is 2/5. Okay, so I just did that by taking 4/10, right? The ratio of their sides, scale factor, and simplifying it. Okay, so this is the ratio of the perimeters. I think I might have said ratio of proportions earlier. I apologize. The ratio of the perimeters. And then to find the ratio of the areas, right? Because we are trying to find area. So I want to find the ratio of the areas. The ratio of the areas is 4/25, okay? Because I just squared those 2 numbers. So here's where we kind of make this leap here. I found all of my ratios, right? I have the ratio of the perimeter. I have the ratio of the areas. Now I'm actually going to take the ratio of the areas that I know, right? 4/25 is how we kind of compare these 2 shapes. And I'm going to make it equal to, right? This is the kind of the smaller portion of the fraction and the larger portion of the fraction. Well, the smaller portion of my area that I know is 27.5, and the larger portion of the area that I happen not to know is x, right? I'm calling it x here. So I have my smaller to larger numbers in my area ratio that I know, and then my smaller to larger area numbers in my ratio that I don't quite know all of it, right? Well, now this is a proportion, and so I can cross multiply, right? Just that algebra piece that we worked on earlier this year. So I'm going to do 25 times 27.5 and 4 times x. And then we just go through and solve this equation, right? So that turns into 687.5 equals 4x. And then we just go through and solve, right? So when I divide both sides by 4, I got 171.875 centimeters squared. So I just went ahead and rounded that up to 172 centimeters squared. I believe in the book it'll be more specific about how, like, what you should round it to at the end. So I'm just going to round to the nearest whole centimeter. All right, so this final example is how do we find ratios when in this case we only know the areas. So one thing I usually start by asking in class is saying, what do we know about these triangles, right? Because we're trying to find the scale factor and the perimeter ratio, which means we're going to need to know some information about the sides. Well, before we look at the sides, do we have any information about the angles in here? We know that they're similar, but this looks like a right angle, but it's not marked. So we don't know for certain that it's the right angle. These angles look like, it sort of looks like they might be 45, 45, 90, but we don't know that for a fact. So we can't actually use any side or angle properties to figure, like kind of work our way backwards, right? Maybe in some cases, if we knew it was like a 45, 45, 90 triangle, we could say, oh, the area is 50 centimeters squared. Let's double that and make a square, right? And then we could like find the side length and stuff. We can't do that in these triangles. We just don't have that information. What we do know though is these two areas that we have. So if I make the ratio of my areas, right, this is kind of the original one that we're starting with there is this 50 over 98. And I apologize, that was my pen, not my highlighter. So 50 over 98 is my like original ratio of the areas. Well, that doesn't really help us a ton, so I'm going to simplify it and see if it helps. If I simplify it and divide it by 2, my top number is 25, and my bottom number is 49, which is actually, those are some nice numbers, right? So how do I get to find my ratio of my perimeters, which I just put up here? Well, since the ratio of the areas is a squared over b squared, right? That's the ratio of the areas. To find the ratio of the perimeters to get to here, I'm actually just going to take the square root of both of those numbers, right? And that'll give me a over b, which are the numbers I want for the perimeter ratio. So I'm literally just going to take both of these numbers and square root them, and that will work me backwards, right, to find just the a over b number, which in this case is just 5 over 7. So then since it also asks us to find the scale factor, as long as we found the ratio of the perimeters, right, we found just our regular a over b, which is 5 over 7, then the scale factor is going to be the exact same thing, 5 over 7. So that's it for today. Your homework is page 638, should be attached in Microsoft Teams. Please show your work as much as you can. I know there's some here where you sort of just have to make your ratios, and it's not really a big deal, but when you have to do those proportions, make sure you're showing your work as much as you can. Thanks.